here. I hope you guys are all doing great today. In this video, I will be going through basic knowledge and formulas of the number pi. I will be discussing about what the number pi really is and some formulas related to pi that is applicable in our real life. There is also a bonus section for experts which you may check out if you really want to. Otherwise, just skip it if you either find it too confusing or uninteresting. When I say pi, you may find yourself hungry and confused with pie. No, that's not the pi I am talking about. That is what I am talking about, the number pi.
Pi, also known as Archimedes constant, is one of the most fundamental numbers in maths. Its value is equal to 3.141592658979323864, and it just keeps going on. So pi is an irrational, don't know if I spelled it correctly, number, like, e square root of 2, etc. But pi isn't just any irrational number. It is one of these irrational numbers where you could do anything, double it, square it, cube it, take the square root, and it would still be irrational. Don't worry though, you don't have to remember that many digits of pi. Remembering pi to 3.14 is completely fine. It is 99.95% accurate. 22/7 is also an easy approximation to remember, and 99.96%. So, in almost any scenario, either of these are going to be okay for you. Unless, of course, you're flying space missions. Pi is used in pretty much every geometric formula involving circular shapes and lumps. Like, circles, cylinders, cones, etc. The two most basic formulas have something to do with circles. So, as we know, a circle has a diameter and a radius. Good. So I'll just put R, so an R showing radius. Remember, the diameter is twice the radius. So the circumference of a circle is equal to the diameter multiplied by pi. Or 2 multiplied by the radius multiplied by pi. Because, of course, diameter equals 2 times the radius. Additionally, the area is equal to the radius squared multiplied by pi, or the diameter squared pi divided by 4. If we just want to find a section of the circle, that's easy. So let's name this angle Q. So the area of the whole circle, as we know, is r squared pi. So, if we just want to find a sector, we need to multiply this by Q divided by 360. We can think of this as 360 units. And then 1 unit is r squared pi over 360. So Q units is Q degrees, which is equal to Q over 360 multiplied by R squared pi. I know that the 3D formulas are supposed to be for the extra for expert section, but I thought it would be a good idea to give just a few 3D formulas for this section. So the first formula I would like to share to you guys is for the volume of a cylinder. So let me draw a cylinder real quick. So remember, the volume of a 3D figure in general is the base multiplied by the height. So for this case, we can take this as the base and that as the height. As we know, the base is the radius squared multiplied by pi. And this is the radius. So the volume of a cylinder is the height multiplied by the R squared multiplied by pi. What if we want to find the volume of a cone? Well, that is pretty easy. Just gonna label these. The volume of a cone is just 1/3 multiplied by the volume of a cylinder, which is height multiplied by R squared multiplied by pi. There is one last 3D formula I would like to share to you guys, and that is for the volume of a sphere. So let me draw that. I don't know if this is accurate, but I think it is kind of accurate. The volume of a sphere is 4/3 multiplied by the radius cubed pi. And the radius is right over here. Now, here comes the extra for expert section, where the more advanced formulas come in. The first advanced formula I would like to show you guys is for the surface area of a sphere. So, have you ever wondered how much peel an orange has? So, the surface area of a sphere is 4R squared pi. Well, this is radius. Now you got it. So the second formula I would like to show you guys is for the area of an ellipse, which is spelled like this. So an ellipse is like a circle, but the two sides that reach from the center to the edges, they're not the same, unlike a circle. So just name these A and B. Then the area of an ellipse is pi multiplied by AB. Similarly, we can calculate the area of an ellipsoid, which is the 3D version of ellipse. This is A, this is B, and then this is C maybe? I guess that's kind of accurate. Wait, not area, hold on. There. The volume of an ellipsoid is 4/3 pi a, b, c. Of course, we need to include the 4/3 because the volume of a sphere is 4/3 multiplied by pi multiplied by the radius cubed. So there are two sorts of ellipsoid. So imagine you've got a round balloon. If you just squash it around like this, then you get an oblate ellipsoid. So this is A, and the height is B. So the top view of an oblate ellipsoid is this. Well, this is the front view. So the volume of an oblate ellipsoid is 4/3 multiplied by pi multiplied by a squared multiplied by b. But what if you take the same round balloon and you just squeeze it to the opposite edges, going toward the center? Then that makes a prolate ellipsoid. So the side view is a circle with B and B. And the front view is the same as an oblate ellipsoid. The volume of a prolate ellipsoid is 4/3 multiplied by pi a multiplied by b squared.
That wraps up my video about the basics of pi and its formulas. I hope you got all the formulas you would need about pi and how to use them in real life. So be sure to like the video and subscribe to my channel, and be sure to tell other people around you about my channel. See you!